Hello, my name is Katie. Today I'll be presenting my research on restoring South African seagrass meadows. Without a doubt, seagrasses play a vital role in coastal ecology, forming the foundation of an entire ecosystem. Seagrass meadows are recognised as globally important systems that contribute significantly to human well-being and biodiversity due to the vast array of ecosystem services they provide. The IPCC estimates that through food security, financial income, coastal protection and their cultural significance, that seagrasses support approximately 3 billion people. But seagrasses are experiencing the 5 most serious threats to marine biodiversity. Conservative estimates show that around 58% of seagrass meadows are in decline. There is concern that the ecosystem functions seagrasses perform will be reduced or, in places, lost altogether without intervention, as is the case for Zostera capensis in South Africa. This fast-growing species does not colonize quickly, and several cases of localized extinctions are documented. So, can we reverse this degradation and restore seagrass meadows? Well, questions remain around the feasibility, as once seagrass cover is lost, recovery may take decades. However, seagrass restoration is possible, with restoration survival rates approaching around 37% and persistence rates of 90%. The declining population of Zostera capensis within Langebaan Lagoon serves as an ideal focal point for conservation efforts, being the only known site containing different genomic lineages of a seagrass species. Cores and shoots were transplanted from the donor population to a recipient degraded meadow within the lagoon. As this is the first attempt to formatively study the restoration of this species, this research aimed to determine the effect of transplant type and planting arrangement on temporal persistence, area cover and species composition of Zostera capensis post-transplant. The material was planted using 3 spatial arrangements across 3 subsites. Initial results highlighted a decline in survival, area cover, canopy height and species composition, irrespective of transplant type or planting arrangement. Yet over time we have seen recovery after a period of initial stress. We have also witnessed lateral dispersal and increases in area cover. These are exciting preliminary results and a key sign of successful transplantation. In the future, we need to tailor techniques to local biological systems and gain a deeper understanding of this species' dispersal and colonization potential. This highlights the fundamental need for further study of transplantation of Zostera capensis to improve long-term success. Thank you all for your time. To my funders and everyone who has already helped enormously with this project, I would now like to welcome any further questions.